If we know who a user is, the next step is to make sure we understand what that user is allowed to access, or their authorization. So authentication was identifying a user, which we've discussed in other sections. But now we're going to talk about what that user is allowed to access, what they're allowed to do on the network or with various resources and things of that nature. So access control is granting or denying approval to specific resources based on who they are and what they're allowed to do. We've certainly discussed in other courses, I'm sure, physical access control like fencing, hardware door locks, man traps, and so forth and so on. Well, we also have technical access controls, which are technology that restricts technology restrictions to limit users on computers from accessing data. So access control is a set of associated terminology and describes and terminology describe those functions. And there are 4 standard access control models, which we're going to talk about, and some terminology. So some of the terminology: identification is the credentials, which is used for authentication, and authorization is granting permission to take some kind of an action. Usually we'll talk about, when we talk about authentication and authorization, we talk about objects, which are a specific resource that someone's trying to access, the subject, which is the user that's trying to access that object, and the operation is what they're trying to do with that object. And so here's a table from your textbook that kind of explains what these different, tries to explain the different vernacular there. But basically, if you take a look at this chart, you have the subject, which is the end user. You've got the actual resource, which is the object, in this case, salary.xlsx. So you've got an owner that creates that file, that owns that file. So there's, some owner of that resource. A subject is someone who's trying to access that resource other than the owner. And the custodian is whoever is responsible for protecting that object, or setting the access control restrictions on that object, which isn't necessarily always the owner, although it can be the owner depending on which model for access control you're using. So let's talk about these different access control models. There are 4 of them, but basically an access control model is the hardware and software and the framework that a custodian can use for controlling access, or setting up that framework for access control. Access control models used by custodians for access control are neither created nor installed by custodians or users. Instead, these models are already part of the software and the hardware. So the 4 major models that we have available to us are discretionary access control, mandatory access control, role-based, and rule-based access control. Let's talk about discretionary first. So discretionary access control is the least restrictive model. It is also one of the easiest to implement and the easiest to maintain as a custodian, because it requires very little work from the custodian. Every object has an owner, and that owner is who controls the access control over that object. So owners can create and access their own objects freely, and they can give permission to other subjects over those objects. So they can give someone else access to do something with that object. Discretionary access control is used in both Unix and Microsoft environments, in Linux as well. I'm sure a lot of you have seen this window, say in Microsoft Windows, where you can add users to access a file that you've created. So if you created a file and you want to give access to someone else to do something with that file, you can do so in Windows. You can provide access. Same in Linux and Unix. You can use things like the chmod command to grant access to anyone to do whatever they want with the files that you create. You can even transfer ownership to someone else. So the weakness with discretionary access control is it relies on decisions from the end user, or the person who created that file, who may not be in the best position to make those decisions. That permissions can be inherited by any programs that the subject executes. So attackers can often take advantage of inheritance because end users frequently have a high level of privileges. So discretionary access, just to kind of sum this for you, is very easy to implement, very easy to maintain, because you're basically leaving it at the discretion of the users how they configure access to their own files. But it can have a weakness in the sense that users are not always making the best decisions with technology. They don't always think about the ramifications of giving someone access to a file, for example, and maybe that they're giving somebody access to a file might have ramifications beyond what they're aware of. So there are certainly some issues with discretionary. Mandatory access control is much more difficult for us to implement, because we have to make all those decisions that I just talked about rather than the end user. So it's also the most restrictive. So Mac assigns users access control strictly according to the custodian's desires, and the user has no freedom to set any of those controls. So in other words, the us as the custodian over the files, if you work in IT security, for example, we make all the decisions as to who can access and do what with, what are the actions that are supported on particular files based on who the subject is. That decision cannot be made by anyone else. So only we can give access to those files when it's needed. So it's certainly a lot more work. Every entity is an object and assigns some classification label like confidential, secret, and top secret. And while subjects assign privilege label, they have a clearance level, which you've probably heard the term, what's your clearance, for example. Usually you have a hierarchy of levels. And MAC grants permission by matching object labels with subject labels based on their respective levels. There are different implementations of mandatory access control. Your book discusses these in much more detail, but the four are the lattice model, in which subjects, users, and objects are assigned a rung on a lattice and multiple lattices can be placed beside each other. Bell-LaPadula is the other model, which is similar to lattice, but subjects may not create new object or perform specific functions on lower level objects. And then the BIBA integrity model goes beyond BLP, or the Bell-LaPadula model, and adds protecting data integrity and confidentiality. And then there's mandatory integrity control, which is based on the BIBA model. It ensures data integrity by controlling access to securable objects. A lot of times when you look at these different implementations in some textbooks, and I don't think our book does this, but in some textbooks they'll talk about no read up or no write down or no write up but allow read down and so forth. In other words, in some of these models, you're allowed to write data above your privilege level, but you cannot read data above your privilege level. And in some, you can write down, but you can't read up. So there's just some different differences in how they work. Some textbooks that you read will talk about how these different models work as far as reading up and reading down and writing up and reading down. But most of them you can kind of subdivide them based on whether it's read up or read down and whether you have permission to do so. One classic implementation of mandatory access control is the user account control in Windows. Whenever you try to access a resource or try to do something that you don't explicitly have access to do, you have to click this continue button. Somebody has to go in and explicitly grant you access to do that, which can be kind of a pain for some system administrators. When I talk about how mandatory access control requires more work from IT security people, this is one of the reasons. Every time somebody tries to do something that they haven't been given access to do that, you have to go and explicitly give them permission, or you have to go and do it on their behalf, which can require a little bit more work. Then we have role-based access control, which is more of a real-world access control. It's based on the user's job function within the organization. So based on what you do in an organization, defines what you're allowed to access and what objects you can take particular action on. And same with the rule-based. Now the difference with rule-based is rather than your access control based on your role in an organization, instead it's based on rules that, it could be a list of rules that are processed in succession to decide whether or not you can do something. So that's role-based. When I think of role-based, I think of things like doctors, nurses, and clinicians. A nurse is allowed to administer medications, but a nurse can't prescribe medications, right? So the doctor can go in and prescribe a medication, so that's something allowed with their role. And nurses are allowed to read what those prescriptions are, and they're allowed to administer those, but they can't modify those. So that might be an example for you of role-based. And rule-based authentication might be rules about who can access which medications. So certain doctors in certain departments maybe can prescribe medications for psychological disorders, and other doctors cannot. So that might be rule-based. And maybe some doctors can prescribe medications that are opioids, and others cannot prescribe those medications. So for example, maybe an eye doctor can't prescribe an opioid, but an orthopedic surgeon can, because they would be dealing with many more patients that might have pain issues, for example. So some best practices for access control, and these I think are covered more in sort of fraud classes. So classes where we cover different ways to prevent fraud and risk and things like that. So I'll just cover them very briefly here. One is separation of duties, which is basically using things like job rotation, making sure there's more than one person that do a particular job. So that's one way. Job rotation, of course, is where people rotate through different jobs so that there's no single person that is the only one that knows how something works. So it makes it more likely that they could commit fraud. Least privilege, so we want to make sure that we think about what's the least amount of privilege that's required for somebody to get their job done. We might use implicit deny, which makes it so that If a condition is not explicitly met, then an access request is just outright rejected until somebody requests access to some thing or some object that they need. And then there's mandatory vacations, which is where you just require employees to take vacations for a period of time, which gives you an opportunity to audit some of their activities because they won't be able to control it while they're out on vacation. So some access control guidelines. There are several technologies that can be used to implement access control. ACLs or access control lists, group policy, which is used in Microsoft's Active Directory, for example. Account restrictions. So access control lists is a set of permissions attached to an object, and it specifies which subjects may access the object and what operations they're able to perform. So when a subject requests to perform an operation, the system checks the access control list for an approved entry, and then either allows them to do that or denies them access to do whatever it is that they're trying to do. Usually with ACLs, each entry is called an access control entry, which is how they do this in Windows. You have a security identifier for the user or group or account, and then the access mask that specifies access rights controlled by ACE, and then a flag that indicates the type of access control entry, and then a set of flags that determine whether objects can inherit permissions. There are some limitations with access control lists, and they are first that they are not very efficient. There's a lot of steps that you have to go through this whole list of ACEs to determine what's allowed to be accessed, so it might be a little less efficient. They can be difficult to manage in enterprise where there's many different users with different levels of access. It can become very confusing. You can very quickly, even though ACLs can give you very granular control over access to objects, they can also, because of that granularity of the control, it can make it much more confusing and much more complex and thus much slower, in addition to much more complex for you to manage. You may not know why a certain user can't access something because the access control lists are so complex. So that's certainly a problem. Group policies is kind of related to ACLs, and this is the in the Windows world with something like Active Directory, which is a very common way for us to for us to implement access control. Active Directory allows granular control of a lot of the capabilities within Microsoft Windows and for custom software applications that can use the group policy objects to manage access control to their own objects. So usually in an enterprise environment, we'll have something like group policies, and all the settings are stored in group policy objects or GPOs. A loop group, so there is this thing called a local group policy, which is sort of like group policy, but it does not have to be part of Active Directory or a domain controller in Windows. So if you take a Windows course, you'll learn about group policies and how you can configure them and set them up and how to manage them, which are all great things. But you can also use group policy without Active Directory, but you get a very limited set of settings that you can configure. It's not as powerful as having group policy with an Active Directory server. The really nice thing, though, about group policy that I should mention is that any settings that you configure in group policy are going to apply globally across the network on any Windows computer that's integrated to that Active Directory network. So, for example, if you create a policy for account passwords, that's applied globally across the organization, based on your group policies. So you can enforce a policy like a minimum password length using group policy. Maybe another example would be if you ever put a USB drive or a CD-ROM in a computer, you probably know that most Windows computers will try to auto-run those CDs. They'll try to automatically, bring up, the contents of that CD or that USB drive and execute whatever it is that's on there that's indicated in the autorun.ini file. That can be a security risk, so maybe you have a policy that disables that capability. It's very difficult to go around to thousands of computers and disable that. This is something group policy would let you do automatically. So in group policy, one time you can set the rule that turns off autorun on for whether it's USB or CD-ROMs or both, and then it applies it across the entire organization. And certainly you can create exceptions to those rules, for certain workstations or something like that if you wanted to. But that's an example of how group policy makes our lives a lot easier as far as access control goes. You can also have time of day restrictions, so you can limit access to objects during certain times of the day. So here's an example where somebody only has access, maybe they don't have access on Sundays, Tuesdays and Wednesdays, Fridays and Saturdays between the hours of 6:30 and midnight or something like that. So this would be an example of restricting access during certain times. You can also have expiration so that accounts aren't orphaned over time. So you can give somebody access to something, but then have that access expire after a certain period of time. That way, if somebody only needs temporary access to something, you don't have to worry about going back and shutting off that access. I think a lot of us know that we can be rather busy sometimes in IT and forget to go and disable access to some resource that we enabled. It happens all the time, and this is certainly one way to prevent that from happening. There are a whole bunch of different services that can help us with authentication. That these are different technologies that you can implement to do authentication. A lot of these different services can also handle authorization in addition to authentication. Really, this should have been in my, some of these services I probably should have discussed in the authentication discussion, but they were covered in this particular textbook in the same unit with authorization for some reason. I'm not entirely sure why. But some of the technologies we have available are things like KERBEROS, Radius, TACACS, LDAP, SAML, and so forth. So Radius is a pretty old technology. It's been around since the early 90s. It was kind of an industry standard for a long time, mostly used for dial-up, really, for remote access. With the development of IEEE 802.1x, port security, and I don't know if I've talked about this in the lectures in this class or not, but 802.1x is basically a protocol where one of the big security problems that we used to have is if somebody walked into our physical plant, if somebody walked into a physical building and jacked their laptop into a jack in the wall, then they would get a DHCP address and they'd be able to start accessing resources on the network. So an attacker, for example, could plug in to a jack in the wall and be able to start running port scans, run Nmap, all those different tools that we learn about in other courses. And they would be able to start getting information about our networks. So how do we prevent them from being able to even connect to the network if they're not authorized to do so? So 802.1x is the standard that has sort of a framework where when somebody jacks into a network device, that network device can authenticate them first before it allows them on the network. And that's a really important distinction because prior to something like 802.1x, you would allow somebody to connect to the network so that they can then authenticate to the network. But at that point, they're already on the network. They might not be authenticated to Active Directory. They might not be authenticated to specific resources, but they're at least on the network and can start doing reconnaissance on our networks and maybe even access the internet through our network, for example. So 802.1x prevents all that from happening. And the way it works is it uses Radius as the mechanism that does the authentication and the authorization as a service on top of 802.1x. So with Radius, you typically have a client. Now, the client in Radius is not the device that's requesting authentication. That is the device like a switch or an access or a wireless access point that's trying to pass those credentials onto the server. So the Radius client is sort of that device that's doing this authentication, not the actual computer trying to connect to the network, as an example. So the Radius server is what authenticates and authorizes the Radius client request and sends back the response to the client, which allows them to access the network if they're allowed to access it. The important thing I want to mention here is I talked about single sign-on in one of the other slide decks. And single sign-on is when we have one single server that's responsible for all authentication on the network. Well, Radius would allow us to do this with 802.1x. So in the real world, we might want to implement 802.1x. But to do that, we have to have something that's going to manage the user accounts. So maybe Radius is the protocol that's going to be integrated with 802.1x. So we have a device that supports 802.1x, like a wireless access point. We might implement a Radius server that's going to that works with 802.1x to actually move those authentication requests around the network and provide the the mechanism that allows a laptop to connect to the network. But then where does it go to authenticate those users? It might go back to, say, an Active Directory or an LDAP server to do that. You may see something like that. I think at Drexel, you have to authenticate to log into the Drexel network, and I imagine that's probably using some variation of 802.1x and some authentication service that's integrating to something like LDAP on the back end, or maybe even Active Directory. KERBEROS, speaking of Active Directory, KERBEROS is the authentication system that was developed by MIT that uses encryption for authentication. It's a three-way handshake. I have here crossed out most often used in education and government because that is no longer the case. KERBEROS is used pretty much everywhere now. It is the standard mechanism that comes with any version of Windows Active Directory after 2008. So if you're using Active Directory on any version of Windows Server after 2008, there's probably a 99% chance that you're using KERBEROS. So it is very common. It's also very secure because it uses encryption. It's sort of baked into the into how KERBEROS works, and basically not only encryption but also digital certificates and things like that. Basically, the way KERBEROS works is you authenticate to the KERBEROS server. The KERBEROS server issues a ticket that you can then use to authenticate to other services on the network, to which it can verify against the KERBEROS server in theory. They're very difficult to copy, so it's difficult for somebody to attack a KERBEROS-based system. It expires after a few hours or a day, and all that's configurable. But that's basically how KERBEROS works. And as I said, this is the basis for authentication in Windows Active Directory. Windows Active Directory is sort of the de facto standard for authentication and authorization in most networks today. So I think you'll find that it's rather common now. TACACS was another one, Terminal Access Control System, or TACACS. It was commonly used in Unix. Later on, it kind of morphed into Extended TACACS or XTACACS, and then eventually to TACACS Plus, which is what we currently use today when TACACS is implemented. And again, I don't see a lot of TACACS. Some of you may have seen it in the field, in the wild, but it's not incredibly common. You know, Radius has kind of emerged as more of the most common method for anything outside of the Windows Active Directory, as far as, you know, doing authentication across networks and things like that, you know, for networking devices. But again, it is something to be aware of. Directory services is sort of the generic term for things like Active Directory. So you learn a lot about Active Directory in Windows classes. If you take a Windows Server course, it's going to discuss Active Directory in some in great detail. You know, and you'll certainly learn a lot about it. X500 is what it's based on, Active Directory services. There was an old standard called X500. So Active Directory is compatible with X500. But Active Directory is, you know, there's a lot of things that are proprietary to Active Directory. But LDAP is sort of an open version of Active Directory. It's lightweight directory access protocol, which means that it's not as functional. It doesn't have as many features as Active Directory, but it's supported across many different platforms, and it works with lots of different software. You don't have to be in the Microsoft ecosystem to support LDAP and to use LDAP. So LDAP works in Linux and Unix and lots of other platforms, where Active Directory is really only common in the Windows environment and with Windows applications. So it has simpler functions than you might find in Windows, but again, it's a good way to implement some form of single sign-on if you have LDAP. Sorry, I have this slide here twice. So as an example, taking a look at how LDAP works. So in LDAP, you typically have an entry. So an entry is sort of a collection of facts about an object. And really not, in that collection of facts about an object, the types of facts that you can store in an entry is defined in a schema, much like a database. An Active Directory, really, if you want to think about it this way, lightweight directory access, or LDAP, is really like a database. It's a hierarchical database, though, so it's a little different than what you learned about in your database classes. And it really is more of kind of a flat file database format, in the sense that, there's not like a relational, it doesn't have all the referential integrity features that you might find in a normal, in a big database engine. But it's a hierarchical database. There's lots of good things about it, but it lends itself well to the types of quick databases that we need for network security. So basically, you have entries that are attributes about a particular object, and those attributes that you can define about an entry are defined in a schema, which I'll talk about here in a second. But basically, each entry, you have an RDN, which can also have a parent DN, So basically an RDN is the object name and value pairs, and then a parent DN can point to a parent in the hierarchical structure. So it's something to which it is dependent on. So a schema, you basically in a schema, you define all of these different objects, or I'm sorry, not specific objects, but you define basically what types of things you can use to describe an object. So you can't just make up whatever you want in an entry. So an entry isn't just a bunch of facts about something that you can just put whatever you want in there. It has to be certain types of facts. Like, for example, if it's a person that you're describing, the schema will tell you that when describing a person, you can give their name, their user ID, and their sex. And if that specific person is a type of student, and you can kind of see the hierarchical structure here, a student may also have a major, a rank, and a start date, for example. So that's a certain kind of person, a student. You can have other types of people. You can also have maybe faculty is a type of person. Staff is a type of person, and so forth and so on. So let's say I have an object called Drexel, and that object in my schema might be college, or I'm sorry, the university level, or the root. And then under that root, I have a location called China. I could have a school called CCI in that location. I can have faculty in that location and a specific faculty member called Kim. All of that put together. So what makes Kim unique in that entry? So if I had Kim, who's a faculty member at CCI in China for Drexel, what makes Kim unique is the combination of all of those things. The fact that Kim is at Drexel in China for CCI and is a faculty member, all of that combined makes that a unique entry. So an entry's uniqueness is the combination of all of those things. And then within each one of those, I can have attributes. So Kim can have attributes. Those attributes are inherited from faculty, which is a type of person, which inherits attributes from CCI, which is the college, which inherits attributes from China, which inherited attributes from Drexel, for example, and probably a very limited set of attributes. Likewise, I could have another entry where the location is Philadelphia, the department is CCI, the organizational unit might be student, and the name is Sarah. And you can see here we're starting to see some of the syntax here with LDAP, where each one of those, has a letter that, for the RDN. So if I were addressing or trying to find somebody by sending a letter, usually there's kind of a hierarchical structure in how you address a letter. So Sarah at Drexel on Market Street in Philadelphia, PA. We also use the same type of address in LDAP. So if I'm trying to address a specific object like Sarah, it's not enough for me just to say that the CN equals Sarah. There could be other CNs that equal Sarah. But CN equals Sarah, OU equals student, D equals CCI, L equals Philadelphia, C equals Drexel is unique to that object. And that whole thing that you see there is called distinguished name. So a distinguished name, or in this case Sarah, has a major, she has a rank, she has a start date because she's a student. And because a student is part of the OU person, she also has a sex, a user ID, and a name. And because that's part of the department, she also has a department. And because that's part of a location, she's also, she also has a location name. And then, of course, she's part of the Drexel hierarchy. So that's a little bit about how LDAP works. So some of the vernacular that you'll see in LDAP are entries, which is a single object. So each user, each computer, those are all examples of objects, and they all have attributes, which are defined by a schema. So a schema tells us what the acceptable attributes are. An object class basically is what we call a schema. So the object class is how you define these different schemas. You can create your own object classes, but there are a lot of standard ones out there. If you implement LDAP, which I'm going to ask you to do in the lab, it's kind of a challenging lab, but you'll see in the lab as you go through the instructions that there are standard schemas or object classes that you can create for things like user accounts. An RDN is the unique ID for an entry, and the DN, or the distinguished name, is how you reference that. It's, for example, in DNS, the parts of an FQDN could be a distinguished name, and they kind of have a similar syntax. DSC and a DC is the root entry. For example, Drexel was the DSE and DC in my example that I showed you. So DC equals Drexel, DC equals EDU, would be the parts for the FQDN for drexel.edu. An LDIF is basically a language that you can use to interact with an LDAP server. So if you have an LDAP server that's running, LDIF is that language or that protocol that you use to ask LDAP a question or to get an answer from LDAP about something. Is this person a user? And you pass in the username. You can think of LDIF as if you've taken a database class and have learned SQL, LDIF is sort of an analog to SQL. It's the way that SQL is how you would interact with a database server, a relational database server, and likewise LDIF is how you interact with an LDAP database server. At the end of the day, LDAP really is nothing more than a simple database. It's a simple hierarchical database. Finally, SAML. So SAML is another technology that we can use for something like single sign-on. So it's very similar to OpenID or to Open Authorization or OAuth 2.0, but basically it allows you to authenticate across different organizational boundaries. The way it works is that a user might attempt to reach a website or service provider that requires a username and password. You can imagine sitting in front of your computer and you're trying to access some website, and it requires a username and password, but you think to yourself, I don't want to create yet another username and password for yet another website, for yet another resource of things that I need to access. So instead, the service provider gives you an option to go out and authenticate from someone else. And you may already be authenticated to that someone else. For example, if you use Facebook or if you use Google, you're already authenticated to those services. And those services are pretty trusted on the internet. You know, they're pretty well respected and well trusted services on the internet. So basically, the service provider generates a SAML authentication request that when you click on the link to authenticate with another provider, it passes the information about the website to which you're trying to authenticate to that provider. That provider then basically checks to see if you're an authenticated user, or you can authenticate at that point to something like Google or Facebook or Yahoo or whatever it is that you're using, or even LinkedIn or some other services. Then the identifier provider decodes the SAML request. They extract the URL for the site that you're trying to access. They authenticate you, and then they send back a response that contains your authenticated username, and you then get linked back to the original website to which you were trying to access. So one of the things that's kind of neat about SAML that you'll see here is there is no direct communication between the service provider and the identity provider. That's kind of one of the interesting things about how SAML works. So the other two that I talked about, OpenID and Open Authorization 2.0 or OAuth 2.0, in those cases, the service provider and the identity provider are directly communicating with each other about you. In this case, you are in complete control of the authentication process. You attempt to reach the service provider. They give you a URL that you can click on to go and authenticate with the identity provider. The identity provider then sends back a signed response that you can then pass back to the service provider. Certainly one of the advantages here is that there is no communication directly between the service provider and the identity provider, so you're in control of that. But the downside is there is no direct communication between the two, although there can be to verify the signatures and the signed request from the signed authentication from the service provider or the identity provider. But that doesn't necessarily have to be. So that's a little bit about how SAML works, and this is just another technique, another way we can implement authentication across organizational boundaries. I've been kind of spending a lot of time talking about authenticating across organizational boundaries. I think the challenges of authenticating within organizational boundaries have been pretty much solved by things like Active Directory and even Unix, Linux, and so forth. Those technologies have been around a long time, but now we're dealing with sort of this next challenge, which is how to deal with the authentication across organizational boundaries, which is becoming more and more common. All of us do it now constantly in our daily lives. We're connecting to lots of different services on the internet in our personal lives, and that same type of authentication is now happening in business, where different services happening across different organizational boundaries have to be utilized by users, and managing those credentials is becoming rather confusing, and managing that access control. So these are just tools that give us some ways to do that. All right, so that's everything about access control and authorization that you would need to know for this course.